Sure. All right. Hi, everybody. Welcome. Thanks for coming. Happy Tuesday. Our announcements for today. I thought we were having an ice cream social tomorrow. Maybe not. I talked with Jim as I was walking over here before my previous class, and he was like, probably not. So we'll find another time. Apologies for that. But there will be an ice cream social or some event at some point. I'm also, as a side note, I'm also in charge of the CS club this year. So if I'll communicate, like if I plan some fun events, or if you are like, I want to do this fun event, come talk to me and we'll make it happen. Okay, can I get a show of thumbs up, thumbs down, thumbs maybe for how Lab 2 is going? Okay. So we got some thumbs up, a lot of thumbs sort of angled down. Can you tell me what's the issue? What makes it thumbs down for you? Just shout it out. Better than Lab 1. Okay. There's less to do. What makes it hard? Just the insanity that is Scanner. Yeah.
I think lab one had very specific of what you were doing.
Mm-hmm.
And this obviously has a goal, but then sometimes I feel, at least for me, I'm not sure about what the first step is.
Mm-hmm. Yeah. Yeah. Okay. So if you're in the situation where you're like staring at the README and you're like, what do I do? That's a case where please email me and be literally in your email, right? I'm staring at step X in the README and I don't know what to do. And then that way I know where you're stuck and I can respond and be like, maybe give you some hints to get started. So yeah, so lab 2 is due tonight. I think, let me go back to this class. Where's lab 2? Okay, so lab 2 is due tonight and it's available until the 13th. I'm probably gonna, if you may have noticed, I ended up removing that like available until date for lab 1. So if you got a bad grade on lab 1 and you want to fix it, you can still submit it. But I think this date is like the goal of, I want to have at least everyone submit something by hopefully today if you can, but Friday if you're really super confused. And if you're super confused, send me an email, come to office hours. I have office hours tomorrow. You can find out where on this info page. Click on it. And here we go. 4 to 5 p.m. Wednesdays and Fridays in Galileo 103A. I'm also in there at 3 p.m. But if any of my 102 students come, then they get priority. But if no one's there, then feel free to come and ask questions. Anything else on lab 2? Any other things that you're like, this is terrible and I hate this so much? Okay, so if you're struggling, send me an email, come to office hours. I would like to help you. I would like you to get 100% on this. Lab 1, I think I've regraded everyone who submitted it to lab 1 and I've left comments on, and so if you want to go through and fix it, do that, resubmit, please. And I'll look through it again. Our plan for today, we're going to finish up input output. So we're going to review a little bit. Hopefully that'll help you with the lab. We're going to do 2 activities. Something with a secret garden, writing it to a file. And we're going to do a Magna Carta activity. And then we will start object-oriented programming. So this is the big part of Java. So all of this so far is how do we do things? And then we're going to get into like the like the main course of this class. Okay, so in terms of what we did last time, all right, this was my testing code. Let me close that. We were in file IO test. Let me close the terminal, zoom things in. Can anyone, I forget what this left-hand pane is called. If you know how to hide it, that would be great. Okay, so what we did last time is we worked with Scanner to get information from the terminal. So where like if I run scanner test, we can enter ints on the terminal and press enter, and then we do things with those numbers in the code. And so we saw a lot of this in lab 1 as well, where like originally with, I think, statistics, where it gets the information of here's all these numbers, and then eventually we transition to command line arguments. But we start with scanners. And so we looked at, let's see, so the best way for our even better scanner, let's use the while loop scanner as our exemplar here. So we set up, so the type of the object is scanner, and the name of it is in, and the other name is str for string. We could name it whatever we want. We could name it sysin if we wanted. It doesn't really matter, as long as it's descriptive and you know what it means and what it's referring to. So we set it up as equal to null in the beginning, and then we have some prompt to the user of give me numbers. And then for this example, since we want to let the user give us many, many numbers, we set up a list of ints. And then we've got our try block. Our try block, inside those curly brackets, that's where all of our risky code goes. So it's spelled TRY and then a curly bracket. There could be a space here. There could not be a space. There could be many spaces. Doesn't matter. Java ignores white space. And then, but within the curly brackets, that's where our risky code goes. And so the risky code includes setting up, here's the scanner, and I'm getting the actual input. And so like str, this could go wrong if there's no next line, if we never give anything on the terminal. And then up here, this is our code to just like actually get all the integers. And then we end up printing the max of our list with the collections API. So that's our try block. So that's where we are getting stuff from the scanner, doing these risky things. Once we have that all done, we have catch. And so in catch, this is where we say, here's what to do when things go horribly wrong. So if, for our case, we're looking for integers, and if we get something that's not an integer, that would be an input mismatch exception. And so in that case, sorry, things keep popping up and I'm trying to not have them pop up. So when we have the input mismatch exception, we print the stack trace. We can do other things here. That's just what I chose to do. So that's the catch. So in parentheses after the catch, we need the type of exception that we're working with. And then we've got brackets, and inside the brackets are what we do when we catch this error. And then we've got a finally block. Finally, we spell the word finally, and then we've got curly brackets. And this is mostly for freeing up resources. So that's for, we say if our scanner called in wasn't null, then we close it. If our scanner called string wasn't null, then we close it. So if it got opened, we have to close it. So that's scanners. And then we looked at file IO a little bit. So we have this method called read, and it takes in as a parameter a string. That's the file name that we want to read. Set it up similarly, file in, start that scanner off as null. And then just for sanity's sake, we're going to print out, here's what file name you want me to read. And then we've got our risky code in the try block. So we are scanning not system.in, but we're going to scan a file name. And in order to do that, we make a file reader object, and a file reader object knows how to open a file and take all that information and give it back to our file in. File in is still a scanner, so we can still use methods like has next line and next line to actually get the text from the scanner and do something with it. So what we did was we had the secret garden. And so up here, I have a data folder, and you're going to have a data folder in the lab as well. And the data folder is just the secretgarden.txt from Project Gutenberg. And so the first test is to just print like the first 35 lines. And so the file in.hasNextLine, we do that to make sure that like if the file had 2 lines, we don't actually accidentally go over trying to print 35 of them. But in this case, the secret garden definitely has more than 35 lines. And so, sorry. So we know that like this is going to work, and count less than 35 is also going to work. So when we run this, so what I have here is I have the count, which is my integer that I'm incrementing, and then I print the line. So I print the number, the line number that it is, and then the actual line. So we can see like line 0 is the secret garden, line 1 is blank, line 2 is by Frances Hodgson Burnett, and so on. So I dropped all of my files. Is this the one that I want? I think so. Okay, so our next step is, let's say we want to save all of these lines to a file. So we have this output that currently we're printing to the console, to the terminal. Let's say I wanted to save it to a file instead, and maybe open that file in another program and do something with it. So I would like to save this output to a file. And so to do that, I'm going to need, maybe I'll change the method name, because it's not only read, it's also read and write. So make sure that my method name aligns with what I'm actually doing in the method. And so I'm going to need a new object called a print writer. I'll call it file out. And just like before with the scanner, I'm going to initialize it to null and then actually instantiate it once we're in the try block. So the type is print writer. The name is file out. That aligns with what I called my scanner file in. So the names match. And then when I look at the variables 5 years later, I'm like, oh, that's a variable to read the input file. That's a variable to write the file out. Okay, so, sorry. All right, so my file in, Okay, so in order to set this up, I would like to have another folder. So I don't want the output to go into my source folder. I want it to go into an actual output folder. So I'm going to collapse all of those, click, whoops. Just so that there's like the blue box outside of here, so that I'm selecting my entire project folder. I'm going to make a new folder and call it output. And then you can see it's on the same level as my source folder, as my lib folder, as data, and all of that. So now I've created a folder. That's where my output file is going to go. Okay. So currently there's nothing in there, but we're going to put something in there. So we're going to set up the print writer, and we're going to say file, and I don't know, I can name it TSG for the secret garden. You name it whatever you want. And I'll say new file. And I'm going to save it in my output folder. And let's say I want to name it line numbers and something. So if I just put file name here, what's that gonna give me? So this is not only what the file is going to be called, it's also where it's going to be stored. So this, when I say output slash, that means that it's going to be saved in the output folder. And then all of this is, here's what the file is going to be called. And so file name, for example, let's pull up, where's the terminal? There it is. So if we go back to the file name is data/thesecretgarden.txt. I don't want the data slash part to be in my new file name. I just want the secretgarden.txt. So I could hard code it. I could say .txt. I'm not actually going to do this. I could say like line numbers underscore the secretgarden.txt. But what if I was given the Magna Carta? Then the Magna Carta with line numbers is now called line numbers the secret garden. And so we don't want that. That's not descriptive of the actual contents of the file. So I'm going to make a substring. So I'm going to call it short f name for short file name. And I'm going to do the substring. And there's a few options. So for my case, the string that I was given is DATA / the secret garden. I just want to get rid of the DATA /. So I can do the substring where we begin, and I just give it, here's where you start at, and just give me the whole rest of the string. And so if we count, D is 0, A is 1, T is 2, 3, 4. So DATA / is indices 0 to 4. So we want to start at index 5. So we were given, let's copy this. And so you can like verify for yourself, you can count up to see that this T is index 5. So once we've got that, now we can be sure that whatever file name that we give it, as long as it lives in the data folder, now we're only going to deal with the actual name of the file. Okay. All right, so we've set up our new file. We have to make sure the output folder exists first. And then we're going to set up our file out variable. So we're going to say file out equals new print writer. And we're going to give it the file name, and the file name is TSG. All right. So we've got this. Now, instead of printing it, let's say we can still print it, but in addition to that, when we get each line, now we say instead of system.out.println, we're going to say file out dot println. So I'm just going to copy. Wow, no, go away. I'm going to copy this line that I wrote and paste it there so that we get the same thing. So instead of printing to the console, which is called system.out, now we're printing to this file that we're saving. All right, sounds good. And then the last thing that we need to do, we've got file not found exception. Maybe we also want a catch for IO exception, because now we're working with IO stuff. What's this warning? Unreachable. Catch block for IO exception, only more specific exceptions are thrown. They're handled by previous catch block. Okay, so I think, so what that's saying is that IO exception is more general, file not found exception is more specific. And so it would probably just be handled by that. So I guess we don't really need this. That's fine. But we do, since we opened our file out, we do need to say if file out is not null, then file out dot close. Okay. Let's test it. It failed. Let's continue. What happened? Read, oh, it's because I changed the method name, but I didn't change what I called. So if I change that and I run it, then it should work. So we've got the same output as before. It still prints the 35 lines. But if we go up to my output, and then I can open this. Oh, it didn't. Okay, something happened that I did not expect. So what are we missing here? We're missing like the title and stuff, right? Oh, I know what happened. What do you think happened? It has to do with next line. Any ideas? So remember, next line is an action, right? It takes the next line, pulls it out, and now we can do things with it. But once we pull it out, the scanner doesn't have it anymore. It's gone. We've done something with it. We've already pulled it out. And so what happens is we print a line and we call next line. And then for file out, we grab the line after that. And so right now we're alternating lines between printing and printing and saving to the file. The count is not changing because that we're not incrementing it in the print statement in any way. So we're still gonna get 0, 1, 2, 3 until 35. But the actual next lines aren't correct. So how can we fix this? Any ideas? Yeah. Yeah. So instead of like as getting the next line at each of these print statements, get the next line once and save it to a variable and then pass it to each of the print statements. And then that way we can be sure that the same line gets sent to both statements. So we'll give it file in dot next line and sorry, we'll give it line, and here we will also give it line. So that way, now we're not gonna be alternating like that. Each output is gonna get the correct thing. So let's make sure of that. So if I run this, then we get The Secret Garden by Frances Hodgson Burnett. And then all of these lines. Let's check this document to also make sure. And there we go. We fixed it. Yeah. Okay. That's our first activity of the day. Printing, so we have the line numbers and we're printing it to, or we're saving that information to a file. The other activity that I have, that's the wrong PowerPoint. Chapter 2, that's what I want. So I'm gonna give maybe, what time is this class done? 3:10? Maybe 15, 20 minutes. So until like 2:15, 2:20. And there's a text file on Canvas. So we can go to Canvas. And in the Introduction to Java module here, we've got the magnacarta.txt, also from Project Gutenberg. Download that, put it in your data folder. Once you're done with that, I want you to write a method or modify the one that we have that prints the first 50 lines of the Magna Carta. And then you can, if as much time as you have, write another method that you can copy and paste a lot of the code. Write a method that prints the first 4 words of the line, and then write a method to print a line only if it's the start of a new section. So like for the Magna Carta, notice that there's sections that start with parentheses, with a number. So you're going to need some logic there to test. Is there parentheses? Then print that line. So print only the first line of a new section. All right, so I'll give you maybe 20 minutes. Work on this, work in partners. I'll also walk around and help. Pause recording while I do that. Let's come back. Okay. So let's let's see, did I download the Magna Carta? No, I did not. Let's download the Magna Carta. Notice that I have a folder named workspace, but I'm not actually in a workspace. That's just what I've named the folder. Okay, now the Magna Carta lives there. Let's try and switch it. Magna dash Carta. Yes.
If I have one method and I make like this, an array list of all the lines in the Magna Carta.
Yeah.
If I make another method to just print out the first thing, like that memory will be gone, right? I do it again.
When you exit the function, the array list will not be there anymore.
So I have to call it again in the new function.
Yeah.
They're like outside. Because I have one that's just like read and write, which just reads and writes the first 50.
Yeah.
But I get various arrays like outside of that, and it'll still be.
You could, I would just copy and paste the code. Yeah, personally, I would just copy and paste the code for this situation. Okay, so let's run it. And so for me, when I change this to Magna Carta, I'm sorry, it just works. This is one of the worst things so far about using VS Code in this class is that it just works, and then for everyone else, it just doesn't work. So apologies, and I can help with that. Okay, so this prints the first 35 lines of the Magna Carta. What do I change to make it print the first 50 lines? Yeah, Oliver. Cool. Now if I do this, here, let me clear this and then run it again. Now it starts at 0 and goes all the way to 49. Great. Okay, so let's see, where was I? What if I only want to print the first 4 words of each line? What do you think I should do? So let me comment out the file out stuff. Something about line. What do I print? I want to print only the first 4 words of each line. Lachlan.
You could split this string by like a space character and then just run a for loop
Okay.
for the 4. And then also add a thing in there to check that it doesn't go out of bounds. Does that split not in argument? Does it already do that?
Yeah. Tell me how you.
I did string and then open close brackets. Line or line words equal line split. Or sorry, the square brackets. String square brackets space. No, not inside the and then just call that line words equal and then line dot split.
And then do I give it
I just the space there and
Yeah.
the for loop where it would equal 0 and then I was less than 4.
Oh yeah. Yeah. So okay. So my first thought was like maybe for words in word list, but since we are limiting it to the first 4 words, then probably I start at 0, I less than 4, I plus plus.
I did a statement to check that if I is equal to the length of your array. That way you're not gonna impact an element that doesn't exist. Yeah, and then you have break.
Yeah,
And then I'm gonna go off screen, so it's all having.
okay, yeah. Um. Yeah, is that, did you use string builder or just a normal string? Yeah, okay. So maybe I have a string first for, and then we'll start it off as an empty string.
Yep.
And then if this is not the case, then we do first for plus equals line words at position I and maybe a space.
And then you would print that.
Cool. Yeah, awesome. So, okay, post-mortem, what did we do? So first of all, we're doing this for the first 50 lines instead of the first 35. And then we split the line. This is also used in the lab, where we instead, in the lab, you split it by commas because it's a comma separated values. But for us, we're splitting it by spaces. And then we start off a string called first for. Originally, it's just an empty string. There's nothing in it. And we say we're going from 0 to 3. So 0, 1, 2, 3, that's 4. And then this is to make sure we don't go out of bounds and accidentally access like the third word in a line of no words. That would be bad. And then we just add, we take the word and we put it here, and then we print it. Shall we see if it works? All right. The text of Magna, John by the Grace, Normandy and Aquitaine. Looks pretty good. And so also notice that like for this one, which clearly does not have 4 words, it only prints 1. So the break allows us to get out of the loop and not go any further if we have reached the limit of the number of words. I also think that I can't remember off the top of my head, but I also think that dot next may work in place of like dot split. Did anyone use next instead of dot split? Dot next gets, let's see, okay, this is gonna break it a little bit. Next, wait, line's a string. Yeah, duh. What's our scanner called? File in. Sorry, this is all system dot out dot. I mean, there is sys out. If I type sys out, then it replaces it. It was just that one line where I was extremely struggling. Okay, let's try. I'm experimenting a little bit. Let's just try printing next. And then, aha, yeah, it does. So next also just prints like the next token. So we could have called next, I don't know, like 4 times. So this is an example of, I like to call it like 2 different ways to go around a square. Like you could go up and to the side or right and up. Like there in Java especially, there's a lot of different ways to get to the same answer. So if you did it by this method, that works great. If you also use .next, that's also great. And this also works for the labs or the homeworks. Like if you found an easy way to do it, as long as it doesn't like go against, like if the point of the assignment is to like actually do this and you just like called a method that does it for you, maybe in that case, that's not acceptable. But for something like this, yeah, there's different ways to go about it. So I would say this maybe is like the hard way, like doing it manually. Next also can just do it like that for us. Okay. How do we check if it starts, if it's the new section? What do we think? What should we change? Yeah.
So I did each line, check, get an index for an open and close parentheses and see if both of them were there. And then saw if there was a difference between them of like 1 or 2 characters.
Okay. That's not parsing in my brain.
I basically just
Sorry.
like line of index for an open parenthesis, line of index for a closed one. And then if they were both in the string, then just minus the difference between them to see if there was 1 or 2 characters between the 2 of them.
Okay.
I wasn't sure if there's an easier way to do that.
Probably. I mean, yeah, so like obviously like that works. That's the thing about Java. Like if it works, great.
I'm trying to figure out a string pattern, but it just wasn't making any sense.
Yeah. Okay. Let's. All right, this is getting complicated. I'm gonna write a new method. What am I calling this method? Print section lines Magna Carta. String file name. Okay. What do I need in this method? I need this bit. So I'm just copying and pasting the code that I had. So I've got my file in. I've got I don't really need the print writer, so I don't need the short file name. Need the count as 0 and my while loop, and I get the line. And then I'm gonna do other stuff here. Close the try. Then I'm gonna take the catch. Did I put that in the right place? This is the other danger of copying and pasting code, is that you can forget something really easily. So if things get weird as we do this, I apologize. And I can help you fix it afterwards. Okay. So we don't need file out because I'm not going to print any, I'm not going to send anything to a file. I'm just going to print it to the terminal. So I've got file in. let's say I'm gonna have a scanner called line scanner that's gonna go through each line. And then in my while loop, I'm going to say line scanner is a new scanner, and it's going to scan that line that I just got. So we set up the file in, and we're still going up to the first 50 lines. And so so maybe I'll have a while loop inside my while loop, and I'll say while line scanner dot has next and words are less than 4, 0, 1, 2, 3. I have to say what kind of variable words is. It's an int. I'm going to print line scanner dot next. I'm not going to do print ln because print ln would put each word on its own line. Ln is new line, but I don't know what it actually stands for, but ln means this print statement ends in a new line. So if I delete ln from there, it doesn't end on a new line. So this does that. So the has next and words less than 4, that ends up doing this, I think, where if we are out of bounds, then it won't try and print any next words. Okay, so and then to make sure that each like the 4 words are going to appear on each individual line, I'm going to add just an empty print statement, and that's going to hit enter for me. Okay, let's try this and see how much I've broken it. Okay, so my method name is print section lines Magna Carta. Copying that, going down to main. I'm calling the method print section lines Magna Carta. Hooray! Something went wrong. Okay, what have we learned? Next ignores spaces. So maybe, where is it? Maybe we add a space there. That works.
I think you're updating count.
Am I not? Oh yeah, no, I'm not. Great point. Okay, so if I update count and words, haha! The text of Magna, John by the Grace, greeting. Yeah, success for at least that second one. Okay, so now let's add in the section numbers. So maybe I'll save the next word, and then I'll grab it from line scanner and save it to a variable, right? And then here I'll print next word regardless of what it is. But now I'm going to have to do some logic. And so I think the easiest thing is maybe if so to check if it starts with the number and maybe just like if the first character is an open parentheses. So maybe if next word. Nope, not a colon. Okay, let's. So for this problem, we only want to print the. We only want to print it, the line, if it starts a new section. So I'm gonna move this line into here. Next word. Oh, how do I get the first character in my word? There's a method belonging to string. Any ideas?
Like, maker?
No, not quite. Say that again. Yeah, char at. Char at 0. Okay, so now this is like a little bit redundant where we don't actually need the first 4 words. Well, actually, what's this going to give us? Only the section numbers. Okay, so maybe instead of this, now we maybe, I don't know, maybe add a Boolean? Not a Boolean. BOO, lowercase b. So maybe if the next word starts with a parentheses, or capital T true, lowercase t true. And then if that Boolean is true, then we print. Nope, that still isn't gonna work. I think we've got to move this bit outside. Oh, and the way that I'm doing this is, for me, it's Option and then the up or down arrow lets me move lines around. Okay. So what are we telling it to do? So while we're looking at each line, I think I don't need this bit for now. I think that's what I want for the printing. If I want to print the line, if it starts with a section number, then I don't need words, but I do need the notion of a next word. So that's, in this case, it's going to be the first word of the line. And if it starts with a parentheses, then I will print this line. And so I can say that if print this line, so if that Boolean is true, then I will print the line, in which case I don't really need a space. Otherwise, I'm not going to print it. So let's see. No. Okay, I think I know the problem.
The next. So we have an exception of line 72.
72. Yes. Okay. So I think this is happening because we have some empty strings in the Magna Carta, right? Like we've got text here, but we've also just got like empty strings. And so when we call next on this empty string, there's nothing there. So I think we may have to rethink it a little bit. Any ideas? Okay. I admit I've also gotten a little bit lost. So I'm gonna take this home and fix this and then tell you guys the solution. I'll also split it into like Secret Garden and Magna Carta 50 and then split it into different methods so that you're sure which one it actually is. Sorry, the code got messy. Okay. I want to at least start object-oriented today so that we can say that we did. Okay, so we're gonna at least start talking about this. We'll go into code and all that next class. I do have a flex day built into the schedule, so input output always takes forever in Java. So we're all good. So our next topic is talking about objects and classes, object-oriented programming in Java. So to do that, first we have to talk about what object-oriented programming is. And so there are 4 principles that kind of guide the way that we do things. And so those principles are encapsulation, abstraction, inheritance, and polymorphism. All big words. What do they mean? So in short, encapsulation is when we're hiding some implementation details and we allow the operations and the data to work kind of under the hood. Abstraction involves allowing our code to work for some generic types. So it's like we aren't hard coding that this code must work for like the array lists of integers. We can abstract it to say it can work with an array list that has any sort of type in it. Inheritance is when we'll see this a lot, especially with lab, I think lab 4, is where we like, it allows us to extend functionality for code that we've already written. And we can say like, okay, for this one, I want to take all the stuff that I had before and extend it or maybe do something a little different. That's inheritance. Again, we'll see all of these examples. We'll go through examples and talk about them in a lot of detail. There's also polymorphism. We've seen this already on one of the first couple days where we had 2 get max methods or max methods with different number of parameters. And so polymorphism allows us to do that and to have different kinds of parameters, and then Java will automatically choose the correct one. And it also allows us to reference objects with different types. And so we'll see what that looks like. My goal is to kind of just go through this intro bit a little bit and then save the rest in the code for next class. So for encapsulation, that's when we're viewing an object as this atomic unit. So the user doesn't get to go in and dissect it and to access things directly. So my example for this is I used to have a Microsoft Surface computer. And one day I woke up and I opened it up and the network chip had failed. So I couldn't connect to the internet. So I took it to the tech bar and I was like, hey, can we fix this, please? And they're like, no, listen, trying to take apart this computer and open it up is gonna break it. And so, and if we tried to do that, then like you wouldn't have a computer. You have a computer that works. We just don't want to take it apart. That's like encapsulation. So we want to like make this its own package and we don't want to go into it at all. This shows up in like information hiding. So we're going to have variables and things that are private that if we're outside the class, we can't access those variables or those methods. Yeah. And so that most often shows up as private or public visibility modifiers. We've seen visibility modifiers so far. We've seen like the class file IO test is public. The read and write method is public. Private just means that any class outside of this file isn't going to be able to access those methods directly. For abstraction, when we were doing the count chars, we didn't do this whole activity. But let me open that back up. What was it? Length of strings? Yeah. So for length of strings, we've defined it to work with an array list. If we wanted to change it to work with an array or an array list of other things, the analogy isn't perfect, but we need to change the function parameters and change how it works. Abstraction lets us define things more generally and then not worry about the having to put in something super specific. So like if you're trying to tell someone how to turn on the computer, you don't necessarily give them directions of turn on like or how to open a word processor. The first steps is turn on the computer and not a super specific, this is where the power button is on this specific computer. It's more general than that. It's just turn on the computer. For inheritance, it's all about extending functionality. We can make new types that have different properties or do different things than the original type. And so like if we are trying to open a word processor, you can kind of extend or modify the rules that you have for whatever situation you're in. So like if I'm on a Mac and I don't have Word installed, then I will open Pages. Or if I'm on a Chromebook and I don't have either of them, then I might open Google Docs. And then, yeah, so for polymorphism, it selects the correct type that for given any options, it'll select the correct ones. So like if I've got my 3 word processors, but I need to collaborate with someone, then I'll probably open Google Docs and choose that one. So those are kind of the 4 principles. And so you'll see in different languages, Java follows all of these. All of these are supported in Java. I think, don't quote me on this, but I think Python in name follows all of them, but it's not as strict. I think it's encapsulation that it doesn't do. But I also could be wrong about that. So different languages can support different amounts of these 4 principles. Yeah, so we are going to be working with classes. We have been working with classes. There are some that are built in, like there's string, there's array lists, there's scanners. And for just a terminology note, so the classes are like this code, length of strings.java, where we have public class length of strings. This is a class. We're typing this, we're writing in the file, our ideas are up in the sky. Once, like house is a class, house.java. But once we actually create an object, when we are in house driver, and we said house SMC equals new house at 1928 St. Mary's Road, now we've created an object. We've created a house object that lives at the variable called SMC. So that's an important terminology note. Where objects are going to be this concrete occurrence, an instance of this class. And so we're going to use those objects to store actual data. So like for the house, we're storing the address, and the address can change depending on what sort of data we put into it. So like the SMC house has the St. Mary's address. The home house has 123 Main Street address. It's got different information stored in there. Yeah, so an object is an instance of a class. We'll talk about members. So the class has members. Let me see if I can. Hold on. I like to draw pictures for this one. I'm so mad at Apple for not having a USB. I don't know if I'm more mad at Apple or just for everyone that makes USB things, but it's not automatically USB-C. Okay. Now go back. Okay, so I like to draw pictures for this. Where's my mouse? So if I think of an object as like just a box, we can have members where we've got like, if we've got fields, which are like variables, we can also have methods. And so this is one of the first days when I was like, our class has things that it does and things that it keeps track of. So fields are things that it keeps track of. Those are the variables. I gotta change the settings on this thing. So these are like, maybe I want to store an int, and maybe I want to store a string. So I can have variables in my class. Those are called fields. I can have methods in my class, like do X or do Y. Those are methods. And together, the fields and methods are the members of the class. You can restrict the visibility of them. You can say public and private. And in general, you're going to see a lot, especially looking at like lab 3 and forward, you're going to see a lot of the fields are private. And that's generally what we want to have. So generally the fields are private and not public. And so there's an example, but I think I'll pause here so that we can have some time for questions afterwards. And on Thursday, we'll go through this and then we'll actually look at code examples. So for active learning today, if you can just make sure to save your file IO test. And let me today's the 10th, and just submit the file IO test.java or however it's named. And then we'll be good for today. Thanks for coming. I'll be here for questions or whatever, for the last 5-6 minutes or so. Thanks for coming, and I'll see you on Thursday. And remember, Lab 2 is due tonight, please.